good dinner plans? Yeah. Going to 1 and 2 dinners, so looking forward to it. Okay, let me get on to the talk. So, okay, so you can see from the title here, I should say that I work at Eigen Foundation. And, one of the things for us is to somehow try to kind of explain when you're doing something that Eigen does, like restaking and restaking deep, what is the actual functionality of it? Because, of course, you could just focus on the fact that it gives somebody more yield, and that is value, but it's sort of like, what do you actually get for that? So this talk is going to be about that. Am I pressing the wrong button? Oh, is it working now, you think? Okay. So I'm going to break down, I was thinking about this more recently, about how to put in the context of what crypto offers, what something like restaking and more of the modular, hierarchical type architectures that are, kind of coming up now. I think Ben's talk just now is a great one, of like figuring out something important like the shared sequencing, doing it privately, and very cerebral, but in the end it's going to like really help out a lot with bringing together many different chains to act as one. So for this one, I'm going to talk about 3 classes of settlement, and I kind of like putting it together this way because it's putting it into a framework. The first 2 are ones that people have seen a lot. There's this meme from a couple years back about money crypto versus tech crypto. People remember that. It kind of set a good context at the point because at the time a lot of people were focused on money crypto and they were trying to remind people there's tech crypto too. The financial one, of course, DeFi, tech settlement is everything necessary to run technology in a trustless way, which is core to the blockchain, but now think about using blockchain for everything that you do in computing around the cloud and so forth. And then there's a third category, which I felt this was a great place to kind of introduce it. In some ways, it's the third, but not the least. When I talk about it, I'll kind of go through in some ways why I feel like the meta settlement class of crypto's value is probably the most uniquely crypto one, and since it underpins both of the others. Okay. Do I have to say each time that I want the slide to move? I should say yeah. Okay, all right. So financial settlement. Next one. Okay, we're gonna have a lot of button presses to do. Are you sure this doesn't work because I build slides?
Yeah, sometimes it works, sometimes it doesn't.
There we go, it goes back. It's working now. Okay. So starting up with financial settlement. Of course, Bitcoin, it's great to note because it's both a financial settlement and it's also monolithic money. It created one kind of stack, going through security, which is the actual proof of work security consensus, the Nakamoto consensus algorithm for fourth choice rule, execution of UTXOs, and finally the application of people being able to send each other money, or the Bitcoin value. And then, of course, okay, next slide, more build. Okay, yeah, just build it all. No, go back. Okay, so Ethereum, Vitalik's great observation was that you didn't have to create a new L1 chain every time you wanted to change slightly the flavor of money. And so he generalized out with an EVM execution the idea that you could write different applications. And so that was programmable money, and then with Ethereum 2.0, the observation was that, well, you didn't just have to stick on the EVM and make it go 1 million transactions per second. You could do what we're doing now, which is have a lot of rollups that are fast, and then build applications on them. So, next slide. Tech settlement, okay, next one. All right, so, and you can do one more build. Or close it down. Yeah, fine, just keep, there's 4 of them. So the 4-sided participants, I want to talk about these in tech settlement for Ethereum. And the reason is I'm going to talk next about generalizing it, which is really key for us to understand what tech settlement means when I say that. So in Ethereum, it's kind of like Bitcoin. Bitcoin was like monolithic money. Ethereum is kind of like a monolithic tech settlement. So you have ETH stakers who have something of value, money that can be bonded to provide security to the system. Validator node operators, those are the people running a decentralized peer-to-peer software network. and they actually do the work of constructing the Ethereum blockchain. And that client that they're running is written by the core devs. That's sort of like the key app or the infrastructure that's being run. And then finally, the EVM users. I'm not really meaning end users through a wallet. I mean, in this case, the EVM users, people that are writing smart contracts and deploying them to the EVM are the users there. So let's build and go to the next slide. Keep going. Two more. Okay, and then you can build out that 4 also. Click. Okay, so Eigen layer, in comparison now, instead of the ETH stakers, now it's just stakers. Actually, maybe I should have said restakers. Shoot. Okay, imagine that says restakers. So restakers are the people bringing security, and now versus just bringing one type of security, they can restake their ETH. Or they can, of course, we have an Eigen that has certain security properties, or they can just bring whatever protocol token they have as well, and they can also do deals with each other and use each other's security. So it's a very shared security, restaking security model. The second is Eigen layer is not monolithic, so I'll go in a little bit, but basically AVSs, just standing for actively validated services, they can be any kind of decentralized software you want to run. Could be a roll-up, could be a consensus chain, of course, but it also could be really interesting stuff around co-processors, around like network timing, proof of locations. It could be stuff around, my brain's going blank right now. A lot of stuff, file storage protocols, file bandwidth, CDN protocols, all sorts of things that you classically might have thought about as, as things that are running in Amazon Web Services, except now the software is instead running in a blockchain model, and then consumers are typically software developers consuming these apps. Let's go to the next slide. Okay. I'm gonna run out of time, aren't I? How am I doing? 5 more minutes? 6 more minutes. Oh geez. Okay, let's go to the next slide.
Next slide.
Okay, and then build it out the whole way. Okay, so we had a picture before about the apps and execution layers, and so the main thing that's been added here is that by putting this shared security, which is intersubjective, we now have the ability to have different consensus layers, meaning the software can do all sorts of different things. Next slide. Okay, build out the slide. Okay, and operators that previously had to do a lot of work in order to figure out how to run one service, like they were going to run Ethereum or Bitcoin, or they were going to run Alio, or they were going to run Filecoin. Now there's kind of a common framework that running and operating is running kind of software that's been normalized into an API that has the incentives, the slashing, the definition for how to join, all the various base components are in there. So this allows operators now to look at this as like a cloud of software to run. And so you have people who have hardware in various data centers who can become generalized. It's a little bit of like a more normalization of things like Infura, Alchemy can now really kind of supercharge. Next slide. Okay, and then this is a category map of just all sorts of different things you would expect you'd want in decentralized clouds that you'd love to be able to do with blockchain. We would love it also because it means we get to write software and have successful companies and make a lot of money. And this was a talk about a year ago that Shriram gave, and then next build. And build. One more. Okay, and so these protocols have all been built now. Next slide. Keep building. Okay, great. So this is kind of a snapshot where we have like 18, 20 or so. There are hundreds of these software services, ABSs in development. And a lot of them you see out here are actually kind of basic infrastructure. Interestingly, on the right side, decentralized AI ends up being one that it's a couple of protocols now, it's gotten bigger. I would actually say I wouldn't be shocked if we go through in a couple of years, we see that category has blown up into the biggest thing we could imagine seeing, because so many different AI protocols are going to come to blockchain. Skip through the next couple slides. I want to make sure I cut. Just skip that one. Okay, and then meta settlement. So meta settlement, the last one, I just want to introduce it. It's kind of a little bit of a far out concept, but it's good to hear it. You're probably going to see it again, because this is an important point about what does crypto really give you in a settlement sense that is very truly unique. And of course it gives you all the trust and everything else, but there's this extra aspect, next slide, which is objective versus subjective false. And objective is the stuff that we're all really used to in general. Like it's stuff that if you give a ZK proof or people are looking on chain and look back at the history, they can execute a VM and they can all see if it's correct or not. There's intersubjective things though, like showing that somebody actually posted data and made it available, or seeing that somebody's prediction is correct or not. Like in Oracle, for instance, you don't really know if somebody tells you on Chainlink that all of a sudden Bitcoin is worth $10. You know it's not, but the fact that they posted it means that it's true, because it's an Oracle. So what do you do beneath that? And in regular crypto, one of the most powerful features that you have is this idea of being able to do some kind of intersubjective slashing. I'll talk about it on the next slide, but all of these go in the category of like promises. So somebody is like saying they're going to do something, and then you want to be able to do a credible commitment against it. So next slide. Just build the whole slide. Okay, so on L1s, the way that you handle, I have 5 minutes left now. Okay, we're gonna go back to the slides. There's some slides on DA and other stuff, it's fine. This is the most interesting in a way, because it's kind of new from a lot of things, it's sort of cultural tech. On L1s, you can slash, right? If you decide somebody has done something really bad, we've seen that on different chains, you just essentially make a copy of the chain and then tell the other people to go kind of F off because you don't think they did the right thing. And we saw that with early Ethereum, right? ETC to ETH. I think there's even one hard fork around there as well. It's just the other fork disappeared even though it's contentious. The ETH proof of work, that was actually a fork, but it lost validity. Everybody thought the proof of stake one was the right one, not surprisingly. It still exists though. It's like, I think, $3 or $4 for ETH token. And then in Bitcoin, BTC, BCH, all of those kind of things. So they're very kind of ad hoc. They're very, very disruptive when they happen. But even though they have all of those properties, they give you something you can't do. Like we can't go to Facebook right now and say, we really think you guys screwed up with the privacy issues. You kind of promised us you were going to be a better company, or Google would be, don't be evil, Okay, it's good they said that, but they don't really have to stick to it once profits are in mind. So, so chain forking is a really important point. And L2s, unfortunately, we want to build all of the settlement that we need for the decentralized cloud for fixing the internet on Ethereum. We're not going to be able to fork L1 every time that we want to do that. So there's this question about how do you take off-chain these types of belief and actually put them in on-chain. So one of the things that we've created is this construct of intersubjective slashing by token forking. And it basically allows a community to decide that there's been a fault and a whole bunch of the security that's behind the chain is stuck in a location where it can't be withdrawn. People put a challenge, and similar to like Ethereum with the withdrawal delay, the resolution happens before people could withdraw, so the bad actors can be slashed. And this sort of thing where you're doing an off-chain belief and then projecting it on-chain, it's more fundamental than the governance token kind of idea in the voting, because it puts a general mechanism beneath what else you've built in a DAO system for those types of things. Next slide. Okay, and so this one I would say, okay, so this idea of meta settlement, whether it's L1 forking or this L2 token forking, allows us to build platforms that break what's happening with current tech platforms. Current tech platforms, I call them opt-in hypocrisies. They've captured our network effects, and if you don't like the new privacy EULA that you see that has 100 pages and you just click yes, then you can leave, Facebook or TikTok or whatever. But in the case here where imagine you have a protocol that's being built for decentralized social networks, and it says, hey, we're going to go ahead and we're never going to push a less restrictive privacy policy, more giveaway information privacy policy without getting 51% of users approval. And now you don't have to click anything. It's like the protocols can be safe. Or imagine somebody builds an alternative to Uber, collectively for drivers with a 5% take rate instead of 60% in some places. So So, you know, if there's ever a violation of that, then people can basically undo those network effects and then move out to another chain through these type of forking things. And so that's sort of the, you know, the inspiration point here. The exciting part for me is seeing that it's possible with Ethereum, with the security, with the programmable money plus, with the tech settlement, that we can actually do this thing, you know, fixing the internet. And a couple years back, I mean, I don't know how many people have been here more than 2 or 3 years. I'm not that long, I've been in crypto for 7. Some people have been here a lot longer. But for a while it looked really hard. I really do think we are at the cusp on this bull cycle, that we'll see substantial new use cases coming over, and I think we will start seeing ourselves able to in fact, you know, fulfill a lofty goal of fixing the internet. Okay, thanks.